because f of x equal to 5 minus x times x plus 1 squared. So number 9 says on part A, find the critical numbers. And all those happen whenever the derivative is 0. So you got to start with the derivative. So here we go. So f prime will require a product rule, right? Because we have two things being multiplied. Luckily, so there'll also be a chain rule during that. So this is like my f and g, kind of. Okay. Since this is called f, you can call these something else. But it's going to be derivative of the first part. I'm going to write it as quotes, just so you know. Then we're going to take the derivative of that one times the second piece plus the first piece times the derivative of this. Oops, that's a 1. 1 squared, so derivative of that guy. All right, so here we go. Derivative of this first piece would be a negative 1, right?
Which rule did you use here?
So this is technically the product rule.
Product.
But during the product rule, there was a chain rule right here. So although it's not that obvious, but derivative of the inside is negative 1. So here the chain rule isn't really a big deal because the insides are basic. They're very simple functions. So now the first part times derivative of this guy. So that would be bring the 2 down, subtract 1, and then times the derivative of the inside, but the derivative of the inside is 1. So times 1 doesn't do anything. Okay. So let's clean this up. This is negative. Let's see here. The 1 doesn't do anything. We're going to have to FOIL this out, these two terms, and then deal with the 2. So I'm going to put the 2 in front and FOIL these guys. So 5 times x, 5 times 1, negative x times x, negative x times 1.
I'm sorry, can you fix it a little bit? It looks pretty blurry.
What's up? It's blurry? I think that's is it the light or what?
I think so.
I don't know, I just see it blurry.
Let's see. It looks clear on my end. Let me see here.
I see it clearly.
If I can lower the light, maybe that'll help. I know when my hand's on there, it blurs up a little bit.
Okay, oh, that's fine.
But okay, so let's go through this slowly, just in case we missed something. So the derivative of this guy is there. Derivative of this is here, right? So now at this point, we're just doing algebra. So multiply all this out. That gave me this. I put the minus there. The parentheses did nothing. So multiply the 5 minus x times x plus 1. That will give you these 4 terms. The 2 I just moved to the front because I don't want to do it all at once, because doing too much at once is confusing. Okay, so we can combine those like terms, right? 5 minus, let's show my algebra steps just in case. I'm going to put the x squared first, 5 minus 1, and then the 5's right there. So finally, we're almost done. I'm going to have to distribute this in order to combine all these terms. So we're forced to do some algebra, sadly. Maybe there was an easier way, now that I think about it. Yeah, actually, there is a shortcut. Let's do
Did you
that.
get the 4x?
F this. It's not wrong. I just don't want to do this. Because I just noticed you can factor x plus 1 from both of them, right? We could do that first before we distribute. That might be a little easier. It doesn't matter though. So notice how they both have x plus 1, right? So I can pull out an x plus 1. So now I have in here negative x plus 1 plus 2 times 5 minus x. So we'll deal with this garbage before we distribute. Because this is a little easier, right? I mean, it's going to be the same in the end, but... So distribute the negative. Put my bracket there. That'd be negative x minus 1. Distribute your 2. That would be, 10 minus 2x, right? I don't know. If you like the other way, that's totally fine. Negative x minus 2, so negative 3x. Negative 1 plus 10. So now we're almost done. So if all this out, you should get negative 3x squared plus 9x. Oh shit, let me do it correctly. X times that. X times this. 1 times this. 1 times that. So finally, we get negative 3x squared plus 6x plus 9, right?
Mhm.
Anyway, it's not an algebra class, but if you have questions, let me know if you forgot any of those steps. You guys okay, or is it weird before we get back to the calculus?
So far, I think I understand it.
Let me know if you don't understand it, please.
Where did you get that minus on the 1, 2, 3 on the third process?
Here?
Yes, correct.
So that's this minus right there.
You just screw down a little, like I
Oh,
cannot see.
sorry.
Okay, right.
Yeah, so this minus right here is this one.
All right.
Because you're factoring x plus 1 out of here, so you're left with one of them. But the minus is still there.
All right.
Then I
right.
pulled out one of these, so only these two things are left.
Hold on.
So going this route is a little easier, but you could have just multiplied all out like I was doing before. I just didn't think it was very clean. So anyway, we have the derivative now. That's this guy. So you set this equal to 0 to find the critical numbers, right? So step 1, find the derivative. Step 2, set it to 0, solve for x. Okay, so if I set this to 0, so set it to 0 to find the critical numbers. So here we go. So factor negative 3. That gives me x squared minus 2x minus 3. Does that factor nicely? What does this factor into?
Plus 1 x minus 2.
Be minus 3 plus 1, right?
Yes.
Okay. So in this section, there's going to be a lot of solving for x. So make sure you remember. All right. So the negative 3 doesn't do anything for us. It will not have any impact because I can divide it out, right? So what we'll do is set each of these to 0 using the idea from solving quadratics, right? So
Mhm.
these two are the critical numbers. So that's part A of that number 9. Let's see, that's what they got. Looks like it. So all that work was to get these guys. Okay. So now we have to figure out where are we decreasing? Where are we decreasing? Now you can graph to check your work, but I'm going to want to see you actually use the first derivative test. So I'd recommend doing it by hand regardless, and then checking your work after. All right, so we're going to need these numbers, 3 and -1. Any questions on before I turn the page?
All right, now, no.
Okay. All right, so part B wants to know where is the graph decreasing and increasing, right? Let me double check what it asked. Find the open intervals which the function is increasing or decreasing. Okay. So part B. Find the open intervals where f of x, the function, is increasing / decreasing. Okay. All right, so remember I told you to use the derivative to guide you. So make a little line graph here. What were the critical numbers again?
-1 and 3.
-1.
-1. So let's put 0 right there, I guess. So -1. This is a critical one. Put a little dot on it. 3 is somewhere over here. Those are the criticals. So I want to know what's happening before, in the middle, and after. Because the critical numbers is where things change. So before this, it's either going to be increasing or decreasing. And then right after, something else is happening. It could be the same thing. It could be increasing and then increasing again. But we need to double check. So we got to find out, is it increasing and then decreasing and then increasing? I need to find out. And to do so, I need to test before and after by plugging in any number into the derivative. So
We only care for the signs, right?
only care about the signs, right? I believe it was this, right? Yeah. Okay. No, ignore that other page. It's Cal 2. Okay, so. All right. So let's pick any number, right? I'm going to plug in -2, I guess. So test below -3. Oh, sorry, -1. So f prime of -2 is equal to -3 times 2 squared plus 6 times, oh shit, yeah, -2. -2 plus 9. Is that going to be negative? This would be 4, -12. 6 times -2 is -12. -12 minus 12 plus 9 is negative, right? All right. Test above -1. So plug in -1. Let's plug in 0 because 0 is an awesome number. -3 times 0 plus 6 times 0 plus 9. Looks like positive, right? All right. Test above 3. Is that positive or negative? Is that right? 9 times -3.
Zero.
Oops. Sorry. I said above 3. I used 3. We already know it's 0. That's funny.
So we
So
put a
go
4,
four,
right?
right?
Yeah, I got you choose anything above.
Or 3.1 or anything.
Yeah. Anything. But yeah, we'll use 4 just because whole numbers are pretty. So that'd be what? 16 times -3. That's what? Is that -48?
Negative 48,
6 times 4.
24.
Looks like negative, right? Okay. So tell me the answer. Where are we decreasing?
Negative infinity to -1,
Yeah.
and then 3 to negative infinity.
Negative
to infinity.
infinity to -1. And I don't know if they might use the union symbol, maybe not, or they might just put a comma. You said 3 to infinity, right? Where are we increasing?
Is on
-1.
-1 to 0.
Yeah. In the middle, right?
Yes.
Now, does anyone have any questions as to where this came from?
I'm a little curious to the right part of decreasing, so 3, 8.
So, all right. So let's look at the graph itself, and then we'll get deeper into what's going on here. Look at the original graph. The original was something I forgot. F of x equals to 5 minus x times x plus 1 squared, right? Okay, so let me show you the graph. Okay, so here's a graph, the original question they gave us right at the beginning, right? So these are the critical numbers. When we graph it, we can see what's happening, right? So from negative infinity, I'm going downward. Oops, I moved it. I'm going decreasing from left to right, all the way down until I hit a critical number. After that critical number, I am increasing up until the next critical number, 3, right? Remember, x equals to -1 and x equals to 3 are the critical numbers. Then after 3, I'm decreasing forever. So that's where the intervals came from. So the critical numbers we tested on paper. Right now we have an idea what it means visually. On paper, we said the derivative is increasing between here and here, right? Meaning the function itself. So I'm sorry, I'm going to rephrase that. If the derivative is positive, then the function itself is increasing between those critical points. If the derivative is negative after a critical point, then I am decreasing until the next one, next critical point. Although it could continue to decrease after the next critical point if there was one. A critical point does not guarantee a change in concavity, which we're going to talk about in 4.4. Concavity is this picture right here. You see how this is opened upward right here, right?
Mhm.
So this is concave up at this point, meaning it is a minimum. This is concave down, which is opening downward, which is a maximum. So the critical numbers or sorry, the function's behavior after a critical point is not always going to be a change in concavity, right? It could continue to keep going downward. They could have hit here and then went down, then went up again. Right? It all depends. So that's why we have to check before, after, and etc. Okay.
Okay.
Okay, let's see. So that's part B. Any other questions on that? Does that make sense or no?
Yeah.
That makes sense.
Mm-hmm.
All right. Let's look at the picture or the problem again. Okay, so that's what we put in here, right? They used a comma. They did not use union. Whatever.
Yeah, it says right there, comma separating the list.
That's fine. Part C, apply the first derivative test to identify the extremum. So we want to find out if the relative extremum is a relative max or relative minimum. So looking at the picture, you can tell right away, right? But without the picture, you have to use this test here. So this is essentially we already did the first derivative test. So from here to here, I'm decreasing, right? And then after I'm increasing, which means relative minimum based on the shape. And then over here, I am increasing, but then when I get to 3, I am decreasing because of the plus minus. Therefore, maximum. So this right here is the first derivative test. That's what we already did. So the first derivative test will tell us where we're increasing, decreasing, and what is a minimum, what is a maximum. So part C, max at -1, comma, whatever it is. Oops, sorry, minimum. Max at 3, comma something. I forgot what the numbers were. Let me check.
It was 32,
32.
the maximum.
The other one was 0 apparently.
0. Yeah.
Cool.
Now, how you gonna get that 32
You just
without
got
seeing?
you plug it into the function, the original.
Oh, okay.
That's it. Okay, so let's move on to 4.4. Now that I'm hoping you remember 4.3 now.
I had a issue with one of the questions in 4.3. If you can answer that before.
Yeah, we could do that. Which one was it, or what was the problem?
More like I thought I was putting the correct answer, and I looked at the practice another question, and I tried doing it in a similar format to that, and still didn't work. So
Which one was it?
it was number 12. the part A.
Number 12, find the critical numbers. So you're going to have to do a quotient rule to find the derivative. And then we set that to 0 to find our critical values. So yeah, I think that's worth doing real quick. We'll do part A and then we'll move on.
Yeah. They just asked for discontinuities as well, and yeah, that's the issue I was having. I mean, yeah, that was the main issue.
Number 12, 4.3, right? So they gave us some ugly function. Let me see. 1 second. Okay, let me write the formula down so I don't make a mistake. Okay. All right. So the derivative of this guy. So first step, take the derivative. So that will be equal to the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, so that would be x minus 9 times 2x minus x squared times 1, right?
Mhm.
Okay. For this garbage out, it's going to be 2x squared minus 18x minus x squared. Okay, so that'll become x squared minus 18x over x minus 9 squared. All right, so that's pretty as going to get pretty much. So now the next step is set this to 0. So that would give us x squared minus 18x.
You move the book out higher. Thank you, sir.
X minus 9 equal to 0. So critical numbers happen, we said, when this is equal to 0, but also when you have division by 0. So we set the top part to 0 and then denominator as well. But you can already see what makes the bottom 0, right?
There's plus 9.
Yes, plus 9. So that's going to be our, let me double check everything. Oh, I'm sorry. It was actually, shoot, if I screwed up big time. The question had a square right here. That's a real shame. So that has a square, that has a square, that has a square, Derivative of this is still good, except there's a square here now. Square there. Derivative of this would be a chain rule, which would be times 2x. So this is wrong. And everything after is BS. Man, I hate when that happens. Okay, let's try this again. So there's a 2 here, 2 there. All right, so we'll FOIL this out correctly this time. 2x times those two would actually be what? 2x cubed minus 18x minus x, 2x cubed. So, is that right? 2x cubed times that. Derivative of this is this. Okay. Times that. Yeah, that's right. So these will cancel, right? Leaving me with negative 18x. That's a little prettier, I guess. So now the question is, what makes the top 0? What makes the bottom 0? So find when f prime of x is equal to 0 and when it's undefined for all the critical numbers. So points of discontinuity can be critical numbers. That doesn't mean that they will be maximums or minimums. Okay. Because if you notice, this is still undefined in the original. So here we go. So you can just set the top part equal to 0 because the bottom makes no difference, right? So that implies that x is equal to 0. Because if I make the top 0, then the whole thing is 0, right? So clearly that's one critical number. So the bottom, you have to set the bottom to 0 as well to find the undefined points. So the square is not going to do anything. So you can just square root both sides, which gets you to here. Move the 9 over, which gets you to here, which then gives you x equal to plus or minus 3 when you square root both sides. So critical numbers are going to be 0, hold up. Yeah, it should be 3 minus 3. One moment. Something seems weird. Yeah, that's right. I don't know why it said that. Anyway, are there any questions on what we did? I mean, the part that was a pain was the quotient rule, but after that, you just find out when is it equal to 0 and what causes division by 0. To find out what causes it, you just set the bottom equal to 0, and you solve. Is there any questions about the algebra or the idea?
No.
Whenever I submit my answer, similar but with different numbers, yeah, doesn't marks it as incorrect. So yeah, I don't.
What was
No,
your question? What number? What were your numbers?
64 minus 64.
Yeah, I think there's something wrong with the question because I see them telling me that the answer is square root 3, not 3, which doesn't make sense. But then when I look into it, it says that it's 3 later. So I don't think it's you. That's weird.
This thing sucks.
Yeah, I think that question just sucks.
I like Alex, the software they used. Alex.
Alex is good at some things, but not others. I like
I gotta
it.
agree there.
But yeah, we'll just delete that question, I guess. No worries. Still good practice. Any question on the ideas behind 4.3? Does it make sense? Like the big picture?
Mhm.
Yes.
Big picture, yeah.
Okay. Let's go to 4.4. So this one's called concavity and the second derivative test. So basically, we're going to be doing very similar stuff. It's just that if you take two derivatives and you plug in a number, it will tell you if it's a maximum or minimum automatically if you plug in the critical number. So we'll find the critical numbers in the same way. But then we'll take one more derivative to find out, is it a max or a min? That way we don't have to test around it. You know how we've been testing before, after, or whatever. This is a different way to get to the same thing. So this method is better, except when taking the derivative is difficult. That's when I don't recommend this. Like if the function is super complicated and doing one derivative just really sucks, you don't want to do a second one, right? But if it's an easy function, then you should do this one. All right, so make a note for you here. No, it's fine. I'll just make it throughout the question. Let's do number 1, I guess. This is determine. That one's too easy. Let's find a harder one. That's fine. Number 1. Determine the open intervals which the graph is concave up or concave down. Okay, so here's the function. All right. You can, if you remember your algebra, you can actually already answer the question without doing any work. Right? What does concave mean?
Okay, like that.
Just look at you.
Yeah, so you, right? So concave up would be facing upward, right? And concave down would be opening down, I guess. So,
Mhm.
but we know this is a parabola, right? And it's positive. So which way is it opening?
Up.
Yeah, it's opening up, right? Does it ever change? Does it move back down? Right, it's always
No.
opening up, right? Forever.
Mm-hmm.
So the answer would be simply concave up everywhere. And if that's the case, there is no concave down because that's everywhere already, right? Concave down does not exist. So that question is not interesting. So let's do something better. Let's do number 3. That one looks pretty good. So same question. Okay. Oops. All right. So the way you're supposed to do this, so step 1 is find the critical values for numbers, which means I need f prime, right? That is to say, set f prime of x to 0 and solve. So f prime would be negative 3x squared plus this, right? Is that correct?
Mhm.
Okay, so set it to 0. Factor this guy. Might have to do AC method, I guess, or brute force. It's up to you, really. But I can divide by negative to make this prettier, right?
Mm-hmm.
Okay. So if you do AC or brute force, doesn't matter to me. We just got to find the inner terms. So factors of 21 that add up to negative 6. So A times C is 21. Factors of 21 would be what? Do they exist? Looks like there's only...
Only one.
Did I mess up the derivative? Double check here. 6x. I think it should factor pretty though. One second.
Is this an instance where we could take the second derivative? Shouldn't they have the same critical points, essentially?
Yeah, I think that's a good point. Let me see.
Because the second derivative is something much simpler to solve for x.
I think you're right. Hold on a sec. Let me look at the book. Yeah. Yeah.
Because essentially that's just the rate where the rate of change on the derivative is 0. Right?
Yeah, because yeah, that's right. You know what? Because when the second derivative is equal to 0, that is called the inflection point. So we should be using the inflection point as the divider between concavity change. Yeah, sorry about that. I forgot about that. Thanks, man. That helps. So we can't find the critical numbers for this particular question without doing the what's it called? A quadratic formula, which nobody wants to do that. But we can find the point of inflection. Since the question did not ask for critical numbers or maximums or minimums, we can just, it's only asking for where is the concave up or down. So find the point or points of inflection, which means set the second derivative to 0. And that's what I forgot. So that would give us negative 6x plus 6. Set that guy to 0. That would give us negative 6x plus 6 equal to 0. Factor the 6 out. That gives us this guy. So x equal to 1 is a point of inflection. Now, what the heck does that mean? Let's look at the graph. Right, it's a cubic graph. All right, it says minus x cubed. Let's see here. Plus 3x squared minus 7x plus, minus 1. So this point, let's see here, 3x squared plus 3x cubed. Yeah, that's right. Yeah, we're good. Just because I can't see it, I'm going to put a number at x equal to 1. Just so I can find it easier. Okay. So what's happening here? So before this point, the graph is opening upward. It's hard to tell from this picture. Let me try to zoom out for you. So see how it's opening up like half a parabola? So from before the inflection point, it's concave up. After this point, the concavity changes, meaning it's opening down. So from 1 to infinity, we are concave down. From negative infinity to 1, we are concave up. So that's what they're asking. Where does this happen? So you write that down. Concave up from negative infinity, we said, to 1. Concave down from 1 to infinity. So sometimes critical numbers end up being points of inflection, which means they're not a max or a min. That happens sometimes. But the second derivative equal to 0 will be an inflection point. So if the question does not ask for minimums or whatever, you don't have to worry about critical numbers. That was my mistake. So 1, 2, 3, 4, 5, 6, 7, 8, 9 are all asking about concavity. Let's see, where do they get interesting?
I think 9 if I recall, 9 gets very, very interesting.
Inflection. Nah, it looks like the same. Let me keep going.
The sign. It's a,
Sign.
it uses sign. I want to say it was 8 or 9. It tripped me up big time.
Inflection. Here we go. This is where it changes. So 1 through 13 is the same BS. They get harder, but this is the same question. 14 through 17, it is a different question. Here we have to find the critical numbers and find the inflection point, etc. So let's start with 14 and do a few of these. Okay. So 14. Find all relative extrema of the function. Use second derivative test when applicable. All right. So basically, you could technically use first derivative test if you wanted to. You could also technically graph it to see what's happening, but remember, you have to show your work on the exam, right? I don't want to see just it's a max, it's a min, and move on. All right, so step 1, find first and second derivatives. So f prime of x is 4x cubed minus 12x squared. Second derivative would be 12x squared minus 24x, right? Is that correct? Yeah, looks good to me. Okay, so set this let me write this more compact. F prime of x equal to 0 gives critical numbers. F double prime of x equals 0 gives points of inflection. So let's find the critical numbers because those are possible extrema, right? So we said, so let's start with that guy. So here we go. So set f prime of x to 0. So that gives us 4x cubed minus 12x squared equal to 0. Just factor your 4x squared. That gives us x minus 3, right?
Huh? No, what's that? Mm-hmm.
Let's see. You guys agree with that?
Mm-hmm.
I don't know too.
Okay. So critical numbers are x equal to 0, x equal to 3. So I'm being paranoid. All right. I feel like we're missing one. Nothing wrong with my derivatives, right? 4. No, there isn't. We're good. Sorry, getting a little tired. All right, so now let's find the inflection point just to see if it exists. If not, we will use this to find out if these are maximums or minimums. Okay. Although this is a fourth power function, so it behaves like a parabola. If you think back to college algebra, they tend to be kind of like a W shape sometimes, but it will be opening upward because of that sign. So we need to figure out what's happening in between at these critical numbers. So second derivative will be set to 0. So that would be 12x squared minus 24x equal to 0. Factor 12x. That gives us x minus 2. Right? Did I do that right? This equal to 0. Factor out 12. Yeah. So x equals 0. X equals 2. So what does that tell us about this 0 here?
There are minimum.
Right. So what do we say happens when you have a second derivative equal to 0?
Gives you inflection.
Yeah, so
You have an upward concave.
at the second derivative, so when you solve for x, we said this gives you points of inflection, right? Meaning a change in concavity happens there. So there's a change in concavity here. But it's also a critical number. So that means that it's not going to be a max or min, it's going to be a point of inflection. So this is point of inflection based on the second derivative. These two are both points of inflection. So only this one is really the min slash max, possibly. Okay. So plug in critical numbers into f double prime in order to find its concavity. If it is concave up, it is a minimum. If it's concave down, it is a maximum. And that is determined by the sign. So plug in 3. So f double prime at 3 is equal to 12 times 3 squared minus 24 times 3. Is that positive or negative? What is that?
Positive.
Positive? Okay. Yeah, you're right. So since f double prime at 3 is greater than 0, then it is concave up, which means it is a minimum. Let's graph it just to see anything, or I don't know if we did. No, we didn't. Okay, so x to the 4th, right? This is the original. Minus 4x cubed plus 7. All right. So here is the minimum, which we said was going to happen at 3, right? Concave up. You see the shape? Or was the point of inflection?
That's 0.
0, right? You can see it change concavity. You see how it's opening upward and then it's opening downward, right? From here to here. And this is opening upward, which gives us the minimum. Since the second derivative is positive here, we have concave up, which is a minimum. Since the second derivative is 0 here, we have a point of inflection. Not an extrema. Is there any questions on this problem? So there is no maximum. That's why they put does not exist. There's only a relative minimum. Don't be tempted to say there's a max at that inflection point. Okay. You guys have any questions on? So the big picture for 4.4 is, can you take two derivatives? Can you find critical numbers? Can you find inflection points? Can you find out where it's concave up, where it's concave down, using derivatives and not a graph? That's the goal of 4.4.
Okay.
I have a question.
Yeah.
For the x equals 2, the point of inflection, how do you test that to see if it's an actual point of inflection or not?
So
I didn't show the graph that you put down.
yeah, I think it is actually. Let's look at the graph again, because it is equal to 0. Forgot about that. Let's look at it again. That's a good point. So we said a point inflection at 0 and at 2, right?
Yes.
Where the hell is 2 at? So right here, we go from opening down to then opening up, which is hard to see. Let's zoom in more. So there's 2. So right here, so it is a inflection point right there. Actually, I could do this, make it easier. What was it? 9, right? Yeah, 2 comma 9. No, -9, I think it was. There we go. Okay, so from here, from this inflection point, we're opening downward and then we're opening upward. So it does change here. It is an inflection point. Okay. Does that make sense?
Yes, sir.
All right. I guess I'll stop here. Do you guys have any questions or your homework problems you're struggling with?
Not really. I can think of at the moment.
I had another issue.
Yeah.
With question 11 on 4.3. One specific part of it, part B, yeah, and they ask for enter using interval notation, and yeah,
Number 11.
part B, I put the increasing part in. I don't really know where the scrap paper I used, but I remember putting it and it not registering for me.
How did you put it?
So let me try and remember.
Was yours 1/3 or 1 something?
1/5.
1/5.
Plus
It
7.
shouldn't
plus 7.
change. Let's graph it. Do you remember what the number was? If not, I'll just put whatever.
Yeah. X to the 1/5. 1 divided by 5
Okay.
plus 4.
F x equal to x to the 1/5 plus what?
Plus 4.
Okay. All right. So here's your
Okay.
graph.
Professor, we can go, right?
Yeah. If you don't have any questions, you can head out.
All right. Thank you, sir. Yeah, everyone.
Good.
Good night.
Yep.
So they're asking for increasing and decreasing, right?
Yeah.
Let's see here. So from here to here, we're increasing. And then after that point, we're still increasing. Right?
Yeah.
So
Yeah.
it looks like we're increasing everywhere except that point
Yeah.
here. Let's go look at the question again. Yeah, it looks like, yeah, you just put increasing everywhere, and then there is no decreasing place. This should take
Yeah.
it.
I got locked out. I put so many attempts. I mean, if I have, do you think I could redo like a different problem, or, I mean,
I don't know. I mean, I'll try to send me an email. I'll see if I can increase the attempts. I'll give it a shot tomorrow.
oh, okay. Well, yeah, thanks.
'Cause
Appreciate
I
that.
know it exists. I just forget where it's at. I gotta look through the settings for a while.
Okay. Yeah, thanks. Yeah. Have a nice night, everyone.
Oh, good night.
Well,
See you, man.
what day is all the homeworks for chapter 4 gonna be due?
Well, I haven't chosen a date. I'll probably keep increasing the date because we're not done and we haven't started reviewing for the exam yet. So once we start reviewing for the exam, I'll probably put a harder date on it. Let's see here. We have all the way till 4/6. So 4/3, which is 4/4. So on Wednesday, I'll see if anyone needs to review 4/4 again. Then I'll start 4/5 and maybe 4/6. 4/6 brings everything all together. Basically, you use the ideas of concavity and max and mins to sketch a graph. So you can sketch a function without using a calculator or knowing what it looks like using derivatives. Just get like a general idea. And then after that, we'll start reviewing. So maybe today is the 5th. So by Monday, maybe Monday, we'll start reviewing for the next exam. And it'll be sometime after that. So I'll close the dates maybe on the 16th.
Okay.
That's my estimate. Could have any other questions?
Yes, can I talk to you, sir, privately?
Yeah, sure.
I have a question before y'all talk. On my exam, some of them, I sent you an email. I'm not sure if you saw it or not, but 3 questions on my exam told me math processing error, and so like it didn't allow me to actually do the problems. Like each answer choice said math processing error except for none of these, and then another question where it was like I had math processing error like actually in the question, so I didn't even see the whole question.
Did you try refreshing the page or?
There's no refreshing in Respondus.
No, it doesn't have a refresh button.
What device were you using? Did you change devices or was it the same as last time?
Oh, no, I use the same one. It's updated. I checked after to make sure that I didn't have an update. I didn't have one. I took photos after the exam and included it in my my work.
Mm-hmm.
And also, I sent you an email with just those 3 questions that it had. Like it's pictures of the problems themselves where it says math processing error. So I mean, like a fourth of the exam basically, I couldn't even take it.
But you were able to see the question, right?
No. So 2 of them I was able to see the question, and one of them actually in the question itself it said math processing error where I believe it should have been an exponent. So I don't know what exponent it should have been.
So what did you? Were you able to take it at all, or did you close it out, or would you end up?
So what I did was I did the problems on paper, and you can see what I did on the paper in my submission of my work. But as far as the exam itself, where I chose the answer, I think I just chose none of these for all 3 of those, just because like.
Yeah, I mean, as long as you have the work, and I think that's all that matters. I don't really care about the answer choices, but I'm sorry you weren't able to see them. I know they do.
Yeah, no, I've actually never had that issue, and I mean, even last semester when I was taking them on Respondus, I've never seen that before. But yeah, on question 5 specifically, it was I believe it's where an exponent should have been. I don't know if there was more to the problem, but it says math processing error, so I was missing part of the problem. So I just kind of did with what it gave it to me. But I mean, if there's any way that I can make up for it, I mean, please let me know, and I'll do whatever I need to do.
Yeah. Let me look at what happened and look at your work, and maybe I can just give you a grade adjustment for what you couldn't see or something. Well, let me see what's happening first and think about it. But yeah, no worries.
Yeah, that's typically a server error. I've heard of it before, but I've never experienced it.
On one specific problem for the problem itself, it said math processing error, and then on every answer choice, it said math processing error. So I couldn't even do anything for it.
Okay. Yeah, I'll look at it as soon as I start grading. I haven't started that yet.
Yes,
That's
what
I was
it's in the submission of my work too, and you can see what I'm talking about.
Yeah, I'll look at it and we'll go from there, man. Don't worry, you won't be screwed over.
All right, sounds good. I appreciate it.
Yeah, I was just gonna wonder when you